Okay, so good evening to everyone and welcome to the second seminars of the sixth edition of ESIC seminars. I'm very pleased and honored to be here and to introduce these second seminars. I'm Sara Favargiotti, I'm professor of landscape architecture here at the Department of DICAM. And as I said, it's a great pleasure for me because today's speakers, with them, with today's speakers, we have shared a long pathway, especially with Lisa. She was a student, our student here, and she's now a professional, a professionist. And thanks to her, I've also emerged in a new, let's say, field and a new perspective of research and thesis, and in particular with the collaboration with Stefan Pollack with his association. And this, I have to say, it was a great also experience, even if I couldn't be together with them inside of this on-site experience. And actually, the topic for today is sustainable urban design with earth, and represent the topic that Lisa and Stefan shared through their work, their research experience, master thesis experience that Lisa have addressed underneath the Talete Honors Program, and based on the long experience that Stefan Pollack made through the foundation of his association Architettura Chilometro Zero. And this is the topic, so particular designing in with natural materials. It's a topic that we like through their voices, their experiences, share with all of you within this framework. And I think it's quite important. Both of them are designers, practitioners, architects, and Stefan Pollack is an architect and a PhD with a PhD in urban studies, architecture urban studies, that have been for many times involved in the cooperation activities, and also expert in a collective design and collective construction, and with this topic of natural materials. And it's, I think, very important to have his experience to share with all of you the perspective on the spatial transformation, the cooperation, the collective design within this context. And after him, Lisa will present her research, master thesis research pathway, as I mentioned, with a practical experimentation in a context that she experienced by herself with Stefan and with many other collaborators. And I think it's also a great opportunity to present again here after many years. She's still now working on natural materials in a wood construction agency. But I think this collective work have been quite important in terms of emotional, in terms of education, and I think it's a great opportunity that's also emerged from the Talete program. And so I'm very happy that we finally have the opportunity to meet you all here. And so I leave the floor to Stefan to open these seminars. Thank you very much.
So while Susanna is getting the presentation, thank you, Sara, for the nice introduction. And we will talk about raw earth tonight, raw earth as a building material. And I'm used to give this presentation to a floor of architects or sometimes civil engineers normally. I know that here the disciplines are broader. We have other disciplines present, so let's try to make it interesting anyway. So. Okay. As a title, we gave the title Raw Earth, Building Material for Both Hemispheres, and I hope it will get clear how I mean this. We will see some examples. Perfect. Thank you. So this is a figure from a few hours ago, the world population, and what does this mean to us? From the perspective of a designer, this means that we have to care about the impacts of our design decisions because they impact a lot of people. And at the same time, we should spend some of our design energies on how we can serve all these 8 billion of people. This is another, how can I say, it's a duty that we have as designers. The building sector, which we are talking about when we talk about architecture and civil engineer, has a strong impact on the energy consumption, for example, but not only. You see it accounts for 34% for itself, as including the production of materials, the heating and cooling of buildings, and all this. But it's even a bit wider because we have other industries, and some of this share also goes into the building sector, as well as the transport. Some of this is also so we can roughly say that 40% of the globally spent energy goes into building. So it's a responsibility that we have to make this more efficient, perhaps. And so this diagram quickly shows what possibilities we have. And so one possibility is build nothing. This may sound weird, but it's actually an option that we can take as designers. If we design the processes and the ways we use the buildings in another way, we can sometimes afford to build nothing and so have less impacts. But we can, of course, decide to build less or build in a more clever way. The last statement here says, build efficiently and especially use low carbon constructions. And so this brings us into our issue for tonight, because raw earth building is a low carbon solution. But we have some other materials that I will quickly mention. We can perhaps use things considered scraps from other processes. They can be resources for ours. And so we get a bit into the issue of circular economy. I think you're familiar with this. Don't need to speak too much about it. But if we go into the realm of natural materials, we can quote vegetable fibers as straw, hemp, or wood fibers that we can use in many different ways. We have vegetable rods. They are different from the fibers. The fibers are very small, and we have to invent solutions to use them, while the vegetable rods can already be considered in some contexts as building elements. We will see this later, so I think Lisa will also talk about this. So bamboo, giant reed, and branches from other woods can be used in this category. And then we have raw earth, and we will see this a bit more in detail. What do I mean when I talk about raw earth? When we source raw earth for building purpose, we normally choose a layer which is underneath the vegetable layer. So the earth that we use to cultivate is the humus layer. This is not suitable for building purpose. We use the second layer. So normally we say between 50 and 60 centimeters below ground. And what can we find in this level? We can find stones, and we refer to stones when we talk about mineral products that have a diameter of more than 20 millimeters. So roughly said, these are stones for us. Then we can have gravel. It's a bit the same, but smaller. We can have sand, even smaller. Or we can have silt. This is so small that we can't look at the single grains, but it has its importance in our blend. And we have clay. The clay particles cannot be seen but by a microscope. They are really, really small. And they have another particularity, which is important to know. If we look at the, I didn't perhaps mention, all of these can be found in earth blends. So all the earths that we will look at tonight will be blends of different shares of these materials. But there's a very important difference. If we look at the first 4 categories, from stones to lime, even if we look at, with a microscope at lime, we will recognize them as spherical grains. So similar to spheres, not really, but similar. While the clay particles are completely different. They have a shape of platelets. So really, yeah, you can imagine them as small slides. And this makes all the difference. This is a picture. If you look at it through a microscope, we will see something like that. And what happens with these flat elements? You can imagine that if they are in the blend in complete absence of water, they will float. They will just slide one on another without any cohesion. We can have the other extreme case that that we have an abundance of water, and so they will perhaps float in the water, but still with no cohesion. The interesting point is if we have the right amount of water, then the platelets will have such an effect. I will show it with a bit larger platelets that I brought in plastic, and I will try to do this without making too much a mess. Let's see if I'm okay, so you see they are completely dry, and of course if I pick them like that, they won't stick together. But just a small amount of water can do the job. So let me see. Okay, we have cohesion. I can separate them and I can stick them together again. You can also try to do it yourself. And until the water doesn't dry, it should work. When it dries too much, you tell me, I give you more. Okay, I go ahead, but you can test this, because that's actually the magic of how raw earth works as a material. The important thing is that this cohesion that we have between the platelets, between the clay platelets, has the capacity of binding even larger elements. So you can imagine the picture here on the right as 3 little clay platelets that hold a very, very big sand grain, because it's on the microscope. The clay platelets are really very small. And so this is actually what happens, and what makes raw earth rely on a physical bond. This makes the difference to concrete, for example, where it is the concrete blends undergo a chemical transformation when they dry, and so they are not reversible, while raw earth can be reversible. I can still add water, and I can re-loose these bonds, which is a risk because I have to take some care when I build with this, but it's also an opportunity because I can rebring the material in its original shape and start the process from scratch, let's say. So how, just one more word on how this works. The magic behind this process are capillary bridges. And if you had the platelet, I don't know where it arrived, if you exactly. You already felt this a little bit. So what happens? What does the water actually do with these 2 plates? It builds a capillary bridge. Capillary bridge means that the drop of water that I put between the 2 plates wants to have a certain shape, because that's a property that water has. It always wants to minimize the surface where it gets in contact with the air around. And so if I do this, exactly the gesture that you are doing with the platelets, so I bring a distance between them, then this shape of water changes, and the tendency of the water is at a certain point to make the process go back, so to rebring the two platelets together, unless I don't, of course, cut the bond. If I cut too much, then they separate. This is clear. Or is this clear, actually? Yeah? Okay. So I wanted to explain this a bit in detail, because this is actually a very important aspect of building with raw earth. It's reversibility. Another important aspect I already told about the grain sizes and the fact that raw earth is a blend. And here you can see what it means to have a good blend with many different diameters of grains. This means that we can pack the material. So we can start with large grains. We can close the little holes in between with smaller grains, with even smaller grains, and even smaller and smaller. And this gives a very compact material, okay? So here it is an abstract drawing, so it's very easy to get really almost closed surface. What we really have when we source raw earth from, actually we can source it from the building ground. That's actually the dream of all raw earth constructors, to have still, since we have to build a foundation, we probably have to dig some earth, and we can test this earth. Perhaps it is suitable, then we are lucky enough, and we can use it. Why is it so important to test the earth before starting to build? Because each earth has different properties. The blend that I was talking about can be completely different. It can have a priority of stones, and perhaps there's no sand in it, or I can have a lot of clay and too small amount of lime and whatever. So the important thing is really to make an assessment before starting to build. The good news is that there are very empirical and simple methods to do this assessment. The one you see here is called the test of Carrasas. This is not important to remember, but it's one of very simple assessment methods. I don't go too deep into this, because otherwise we can talk about everything. The different earths, the different kinds of earths can be shaped in different ways. And with this diagram, we refer to a category, to a classification made by Crater. Crater is probably the most important research center on raw earth building. Its headquarters in Grenoble in France. And it's not important to go into each building method that they classified. The interesting thing is that they classify them according to the gestures that you do to build. So that's why you have, sorry for the Italian, but that's why you have these verbs here at the bottom. But what we can perhaps have a closer look to it is that they can be redivided in 3 big families. And we see this here. We have monolithic techniques. We have techniques that we can refer to as masonry, and we have structure. Structure is the case where raw earth is applied on something else. So this can be, in this picture, it's wattle and daub. So it's a structure made of giant reed. And this is the support for an earth layer. But the earth layer is not self-bearing. Masonry is quite clear, I think. You know the word, but we refer to masonry in each case when we have a building component that is small enough to be easily taken into a hand and assembled to become a wall or something else. This is masonry. So these are adobe bricks, raw earth bricks, but we will see some other applications also. While the monolithic techniques are those where, if I imagine to drill a hole through the wall, I will always find the same material from the beginning till the end. So in this sense, they are monolithic. Okay. And we can see applications of this. I will go quickly through these, just have perhaps a look at the, I indicated the countries where these pictures are taken. So here it's Côte d'Ivoire. This is southern Germany. Here you see this is a case of a structure, of course. We can appreciate it because the earth layer actually fall down. Otherwise, we wouldn't see it. Okay, this is Lima. The center of Lima is constructed with this same technique. These are buildings from the 18th century, more or less, so almost 300 years old. Again, here we can look at them because in one of the recent earthquakes, the earth layer fell down and shows us the reed structure, but they are supposed to be covered. But we can have modern buildings. This is the urban lab in Divjake in Albania. I don't know if I pronounced it right, by ARCO, an Italian design group. And if you look at a picture from the building site, you see it's made with the same technique. This is a traditional rural house from the early 20th century, sorry, in central Italy, in the Abruzzo region. But we can have large public buildings made of earth. This is a school in France, for example. This is from the same school picture of the inside. You see the character is still very rough because it's a natural material used, but in a completely modern building with combined with other materials and with a purpose. It's not only fashion. It's this has the double purpose of mitigating the climate, because raw earth has the capacity to absorb differences in humidity. When the air in the room becomes very humid, raw earth can absorb this, and so stabilizing a bit the inner climate. When it gets dry again, raw earth can give this water, this accumulated water away, and so really have a stabilizing function. The second purpose is acoustic, because it has quite a lot of mass, and so it can divide from one schoolroom to the other. It's a good acoustic insulation. This is a picture from research in Switzerland, where we have Gramazio and Kohler as a research team from the Polytechnic University in Zurich, and they experiment with robotic and raw earth. So we can also have this. Sorry for the D on the other. So this is an experimental project they did. They built into a parking lot, I think, or a storage building, and it is a pavilion for chamber music. But it is built by the robot you see here. So every little piece of this, every ball of raw earth is placed in exactly one design point, which was pre-stabilized and then put by the robot exactly in this place. This is also possible, and we have an Italian application of the same method. This is the first 3D printed house made of raw earth by Mario Cucinella Architects and WASP. So also an interesting application. If we have a look at the monoliths, we can talk about the Tulu in China. These are large family buildings. Actually, whole dynasties live in one such building. And they have, I don't know if I put the picture now, they have very thick monolithic walls all around, which also help as a defense, of course. But they also hold the rest of the structure, because as you can see here, I had a pointer there, I can use it. As you can see here, the inner structure is a timber construction, which is held by this thick wall on the outside. And you see, this is a typical typology that is replicated. At a certain point, they started to do it as a square, but traditionally it used to be round. Okay. This is a traditional farmhouse from the Val d'Isère. Which is interesting about this is that, as I said, raw earth is fragile because it is reversible. And so it's important to have a good head and good boots. And this is clearly shown here in this picture. They have a roof that stands out more than 1 meter and protects the wall. And the stone wall for the basement avoids that capillary humidity can grow towards the earth wall. So the earth wall itself is protected. But we can have earth buildings in metropolitan area. Since the issue of tonight is urban building, I wanted to show you this also. And we can have it with a very modern look. This is a private house by Martin Rauch. Martin Rauch is not an architect, but he is actually a clay maker, and he then got this expertise to make consultancies for architects building with raw earth. And he, at a certain point, he asked one of these architects he used to collaborate with to design a house for himself, and he wanted it specifically modern with a flat roof, with this square design and so on. This is a school building again in southern Switzerland, in Ticino. This is a hotel in, or no, a private villa, sorry, in Brazil. And you see the monolithic structures, they are built with frameworks, exactly as concrete structures are built. And which is interesting because then you see the layering of how the earth was processed during the building. And this tells a bit the story of the building process. This is quite interesting and very typical for rammed earth constructions. This is a university building in Rwanda. So just to show that we have really, excluding the Antarctic, we have all continents with raw earth buildings, with interesting raw earth buildings. Here we are again in Germany. This is the headquarter of a supermarket chain, natural supermarket chain, so something like Alnatura. This is called Alnatura, something like Natura C here in Italy, if you know it. And they decided to build their headquarters also with a rammed earth facade. Inside, this looks like this, and I had the opportunity to visit this. It's really a very comfortable working ambience. And to build this, this machinery was specifically invented, not really for this building, for a building before, but this is where the facade for this was built. I cannot go too deep into it, but just keep in mind they hired a hangar of 110 meters length, and they built this machine that contains the preparate blend of raw earth, and then it goes here. The second board is missing, so you have to imagine this with a second yellow board, and then the earth is poured here inside, and these are the rammers. 2 rammers like this, and again 2 rammers like this. And this whole train, imagine it like a train, floats on this system and builds the whole wall. This was important. The architects wanted this like that because they wanted these lines perfectly aligned. So what they did was actually build the whole wall and then cut it afterwards to be sure that the layers are really precise. Okay. Now I switch a little bit. I will spend a few words on the organization I'm part of. It's Architettura Chilometro Zero, a small organization based in Rome, and I will tell you in a few words what we do. We have mainly 3, how can I say, spheres of activity, and we like to call them with these words: build, learn, explore. where build includes design. We do also design practice, or consultancy. We help other professionals to get their designs done if they need this specific expertise. And sometimes we also construct directly, and I will show you. This, for example, is a school, a trade school in Guatemala. And here it was important to send a team directly on site, because we wanted to introduce the building with raw earth. We thought that this would really make sense in this context, because the material was available. The stakeholders on place could be involved. They could help in the building site, but this only works if there's a presence of people from the design team who have also this expertise. And so it's a process of building together. Bit the same story here in Côte d'Ivoire. Here we go already into the context that Lisa will also show us later. Here we are in the village of Trento. This is a building where we had the wish to do exactly the same, to send a team and to hire professionals on place, and then build it together, and to bring all to translate the design into build reality, and while doing this, solve also all the technical problems. This was built in 2021, so we couldn't do that because we couldn't travel at that time for the coronavirus crisis. And so we tried to do it anyhow with some video conferences per Zoom and telephone, and sending more drawings that we actually had foreseen. But at the end, more or less, it worked. And if we say consultancies for other designers, for example, this is a very small intervention in a flat in Rome, where the kitchen counter is actually built in raw earth. And so here also we helped manually to build it, because this expert, there was no company, no enterprise available to do this without knowing before. So we did it directly. It was small enough to do it like that. Okay. The learning category includes training programs and dissemination. So dissemination are, for example, reports that we publish on building techniques. Some of them are available online. I can give you the links if you want. And the training is normally a very active training. So it's a building by learning by building, actually, experience. This is what we do mostly. And therefore we have a program, a 3-level program. So this is more or less, the first level is an introduction in the categories of building with vegetable rods like bamboo or giant reed. And then we have the building with raw earth introduction. We have, this is also building with raw earth, but we keep it separated as render, because this is the most simple application that you can do in a building process. If you don't dare to build a house completely in raw earth, at least you can give it a raw earth render, even in a metropolitan area like the center of Rome. This is possible, and we did it. And then these are deeper applications, or more detailed courses on the same issues. And then actually the third level experience is the participation in one of these activities. It's more or less what Lisa did with us, spending 3 months in Western Africa. And just to, this is an information I got this morning from the organization. This will be the next workshop if someone from the floor here is interested in spending some days in Ostuni, in Puglia, also very nice place to to go to the beach. And this will be on lime, not on raw earth, but it's the next workshop by AK0. So we then, at a certain point, we tried to apply this workshop concept to Africa, and we had really good experiences with it, because the learning by building process is actually what works. The fact that you share the building site and you do it simply. And in this sense, raw earth is a very forgiving material, because you can easily repair errors. And in this sense, it's perfect for practical training. You can just start where you can, do it. And if it's not perfect, it can be done again. It's not a real problem. In this case, it was the village of Babrasu, where we started such a training workshop. And in this case, we were really surprised, because those who participated were mainly women. And we didn't expect this, but it was nice. Okay, and a few words on the Explore. This is a bit more the research aspects, research and experimentation. This includes very conventional things like energetic assessment of some buildings, where we endeavor things like what can come from a raw earth render. Does this really improve the inner climate? Things like that. This is an issue that we are very interested in, prefabrication and self-construction. Can those two aspects go together? Because self-construction is a very interesting social aspect. It means that those who build their home can bring their own resources, their own human resources into the process, not only in terms of labor, but also in terms of experience and knowing the building. This is something that I consider valuable, should be enhanced. But at the same time, we have to cope with norms. We have to cope with building codes and all of this. And so perhaps it can be interesting to share the responsibility a bit, to have some part in prefabrication, that till a certain point we have a company that can perhaps build a good timber frame and bring it on the building site, and then we can do the finishes on our own. And so this is a bit behind this. Then this is just to complete it. We have one aspect of our research is called digital nature. So here we trying to understand a bit what can we do if we use digital algorithms to control design process, but with natural materials which are not homogeneous at all. So sometimes you have these figures that come very cleanly out of the computer software, but then you have to cope with a bamboo rod that has its nodes where it wants and not where we want. So this is sometimes a problem and has to bridge. Other investigations have a more urban character. This is the city of Pricro in Côte d'Ivoire again. This is a place that Lisa also knows very well. And it's a medium size city in central Côte d'Ivoire. It's more or less 10,000 inhabitants itself, but it's center for a province of almost 100,000 people. And it's very fast growing, which is actually what is happening in a lot of African towns. The UN Environment Program estimates that 70% of the African building stock will that we expect to have in 2040 still has to be built. So we were interested in understanding how will they build, and can we somehow perhaps give some little hints, even if, I mean, it's a process which is ongoing and very fast. So, since we had the opportunity to work with local craftsmen who handle the techniques of raw earth and who learned to build with bamboo, we found it sensible to investigate a process of urban renovation built on these two techniques. And so this is a bit the base cell of this process that we imagine. This goes a bit into building construction, so basement of raw earth and the upper floor of very much lighter of vegetable rods of bamboo, as I said, which is available in place. They have bamboo not cultivations. They have bamboo available, but they have no notion on how to use it because it's not part of their tradition. So this is there an input of know-how can actually perhaps change something. I don't want to make this too long, but we then thought about different typologies. Is it only living, or is it living and economical activities like small shops or small workshops? And also how can it grow through the years? If the family grows, perhaps it can grow. And this, all of this included in an urban pattern which is existing. This, I forgot to say this, what you see here, these are actually buildings that already exist, but the municipality already draw this endless pattern that goes along, and there will be new plots exactly that way. So this brings us already quite close to what Lisa will tell us, but just perhaps once more, this experience that we made through the years, that the building site itself can be the center that links these three spheres of building, learning, and exploring. This can really happen actively on the building site. And this is also something that generates enthusiasm, collaboration, and trust also. What you see here is this big hug. There are people here, are those who build it, those who paid for it, and those who have to use it afterwards, and they are apparently all happy. So this is exactly what we did then later with the program ABRI, which stands for Architecture et Bioconstruction pour l'Environnement Rural Ivoirien. So a specific program tailored for Central Ivory Coast. And we started this with a workshop in collaboration with Romatre University. They came to Pricro in 2019. And then this went a long way. You will probably re-see this photo here. But this is just to say that the last output of this program is a process that we did in 4 different. So after doing the program in Pricro, which is here, we extended it to 4 other localities, to four other sites. And our partners on site are an association called Eau et Miel, so water and honey, because they are beekeepers mainly. And well, and then they have also this other program aspect with water. But what they needed were buildings for their beekeeper activity. This differs a bit from site to site. Sometimes it's only a place where they can store their equipment. Sometimes it's really a larger building where they also can do training activities and things like that. And so we had the opportunities through these active building sites to meet the people who will then need these buildings, and to do the design process really as a shared and participative process on site. And so I will quickly show you the last proposal. This is in the locality of Tanda. Tanda is here in the very west, yeah, close to Ghana. And so here at the end, what we did, the design recalls a little bit the hexagon, since they are beekeepers, and since the plot was triangular, this was a bit. And you see it's quite a complex building for the region. We have a training place. We have here the whole processing of for the beekeeping process. So where the honey enters from outside, and then how it is processed till to be then sold in a small shop, which is also a little cafe. So this has also this urban aspect. And this has now been presented to the municipality of Tanda, and we're waiting to do this. And meanwhile, we have to see how we can finance it, because this is not 100% clear still, but as usual. But this is something we always managed, so I'm positive on this. So, and this is perhaps a good point to pass the floor to Lisa, because she actually will present you an experience which is very similar, because the client, if I can say it so, is the same. It's the organization OML, and the site is different, you will tell, and also what the building will be used is different. But here I will stop and pass the floor to you. Thank you.
No, no, non ti preoccupare, volevo solo duplicarlo. Ani, riesci a rispondere alle domande in chat? Perfetto. Allora. Cioè, dovrebbe esserci forse la possibilità di duplicare lo schermo. Questo. Esatto. Eccolo qua. Questo vuole fare così. Questo così potrebbe andare. Questo lo facciamo così. Ani, mi dici se si vede su Zoom? Perfetto. Adesso sì, forse non so se il tuo è collegato, ma forse è un po' no, provare con basta.
Okay. Okay, good afternoon to everyone. I'm Lisa. It's a pleasure for me to be here. I'm a civil engineer and architect. Before graduating in 2022, I became interested in sustainability and circularity of architecture. Today, I will present you a case study of my thesis, a project using bamboo and earth. I will discuss the objective, methodology, and also the result. Now I work at Forwood, that is a company in Belluno of bioarchitecture that's build natural energy efficient wooden houses. I work in the technical office where I handle cost estimates, drafting, but also drawing and design. These are two photos. The first one is a photo of a private building that we made in Cortina with CLT wood and also reclaimed wood. And the second one is our office that we built with a timber frame structure. I developed my thesis through the Talete Honors Program, a training track parallel to my degree program focused on global interdependence and international cooperation. The program is structured around the two central experiences: the field research for the thesis, which I did in Pre-Cro in Ivory Coast between January and April 2022, and the postgraduate internship, which I completed in architectural firm in Verona, specializing in the use of wood and straw. My thesis was supported by AK0, the association of Stefan, the local association OML, that is founded in 2001 to improve working, living, and environmental conditions in rural African areas. And also Bamboo Strutturale, that is a research team for the more technical aspect related to the material bamboo. The entire process of this thesis allowed me to exploring a new context, new material, and understand the value of natural material. Also participatory design and the respect for the environment. In fact, during my stay, there were a lot of training sessions aimed at raising awareness among the local population and young building who, like me, want to follow the path of the ecological construction. The field research was also an exercise of reciprocity, because the people involved have established a relationship of mutual learning, so in which everyone could give but also receive, despite different differences in role, age, and culture. The research also made it possible to understand the needs, the available resources, the skills of local builders, traditional technique, traditional construction, and also the feasibility of the new project, all through a participatory approach. This method improved the quality of the design by bringing together different skills, expertise, but also experiences, and involving the end user themselves among the old stakeholders. The first goal of the research was to explore local techniques and materials in order to select the most suitable one to use in the project. It was made possible to, thanks to the assistance of local association and young builders, with whom I conducted sites visits, studying the earth with its properties as a building material, and investigated traditional material and construction methods. Like Stefan already said, I understand that the soil is a composite material, so it can be very different to one to another. To comprehend the soil, if the soil is adaptable to a construction, there are some empirical tests we can perform. Like there are many, so the Ball test, Carrasna test, and others. These are some sheets I realized to classify local buildings, while these are the most common types of construction that I saw in Ivory Coast. The model earth, or Beninoise in French, compressed blocks, adobe bricks, bouge on poles, and bamboo cladding. The second goal, the central goal of the research, was to design a sustainable low-impact project that could be realized with the local human resources. The project concerned a center for the resource and artisanal soap production of the OML association in Jebonois, that is a rural village in the center of Ivory Coast. I have studied compositional, functional, but also structural aspects of the project. For the local association, this project represented an important step toward environmental protection, the recycling of waste material, and also training to create new jobs for the local population. The last goal, the third goal, however, was to analyze the project's practical feasibility. So the construction were organized into some phases that they were simple and flexible to adapt the project to changing needs and financial constraints, and to allow the building beginning operation without waiting the end of the construction. The methodology of this research were organized into as follows. So the first step involved researching and reading reference text on material, but also African context. And then I participated in a workshop organized by AK0 in Benevento, focused on traditional and prefabricated rammed earth, which was really useful for me for learning the construction technique and also for beginning to work with the raw earth. Then I left for Ivory Coast to conduct the field research of my thesis. And during this phase, we organized a training session with AK0 for local builders on the use of sustainable and eco-friendly construction techniques. During meeting, a small training site, we build full-scale prototypes to explore the use of rammed earth, bamboo, and wood as a building material to be utilized as their great potential. The PISEC technique was studied by conducting tests with a young local builder to understand the soil, then designing and constructing a metal formwork for a standardized construction system, and then building a prototype with a wall made of traditional pisé, stabilized pisé, and also adobe bricks. These are some photos of the formwork on the top, and then the prototype made with rammed earth. I also conducted some studies on bamboo, that is an eco-friendly and sustainable material that is rapid, renewable, and also has excellent physical and mechanical properties. In the field, we work with local builders to construct a bamboo truss and a section of bamboo and earth floor. This prototype helped us gain a better understanding of the material, but also its workability. This is the truss we made with Stefan. And then the small floor made with bamboo, and then the other step of the prototypes with the earth. We also consider the fragility of this material, which is easily attacked by mushrooms and also insects. So we decided to design and build together an earth brick fireplace to treat this material with the fumigation which increase its durability. Then, after gathering all the information on the material, on the techniques, I drew up some plans that I showed to the association representatives to discuss the various design issues that had emerged in the field research. Once the field research was completed, I conducted a literature review, and then I synthesized the collected information, maintaining close communication with the local association. Finally, I created a connection with some bamboo stalks to test its feasibility and also the replicability of the system. Let's talk about the results of these results. First of all, I studied the project site located in Jebonois. So through visits, photographic reports, soil tests, discussion also with the local builders and the residents, and by giving some questionnaires which offered a different way of experience the space. Then I identified the main objectives of this project, and I grouped them into 3 categories. So the work, the community, but also the construction technology. The most important goals are replicability of the project, but also the comfort of the spaces, the creation of new skills and jobs. But the central goal for the association OML is to reduce the exodus of young people to cities and Europe. After studying the soap chain, the soap production chain, thanks to the creation of a prototype with an expert, it was possible to understand which activities will be done in the 4 main areas of the complex. That is the research area, production area, waste management, and sales. Specifically, the soap production in Jebonois will be made with palm oil, coconut oil, and honey. And the waste from this production will be reused to produce vegetable charcoal in the center. Then I analyzed the production flow to better understand the quantity and the direction of the materials in the center. This allowed me for a clearer definition of the spaces, their dimension, but also the connection between the different areas. The concept for the project emerged from observing how many people spend more time outdoors than indoors, often treating the trees like they were real rooms. So we decided to create a sort of bamboo forest that embraces the production spaces, which are instead designing using rammed earth. The result is a shell that protects the rammed earth both during construction and throughout the building's lifespan. This shell in bamboo also collects rainwater, allowed natural ventilation and cooling, and at the same time managed to create covered spaces, but also open. The master plan reflects the intention to create a new permeable square with buffer zones that preserve the existing vegetation and pedestrian areas that are connected to the factory. The PSA modules with production, retail, training, but also meeting spaces are independent, while the external bamboo structure is a single large complex. The center has also some versatile areas that the association want to use for training section, for awareness raising activities on topics such as recycling and sustainability. The waterproof layer on the exterior structure in bamboo consists of a lightweight recyclable vegetal sheet that is made with leaves, and it's called papo. These renderings help us to visualize the structure, how the structure fits into the local landscape. We see the exterior structure in bamboo, but also the walls in rammed earth. The interior furniture was designed to be made by some bamboo processing waste. So, and then the rotating door makes the space more flexible. The two design systems, so the bamboo envelope and the rammed earth walls, work together. In fact, the walls help to wind brace the external structure in bamboo, which consists in a single building with a central rectangular courtyard. So for the structural analysis of this envelope, one of these trusses was chosen as the model for the analysis. Then we made two calculation tests for the compressive instability, because this is an important phenomenon to consider when we design a bamboo structure, because bamboo pole is particularly slender and imperfect. So these are factors that can compromise the stability of the structure. Then in conclusion, I think this experience was a wonderful challenge. The field results made me work out many studies, but also practical experiments. I've learned a lot from the people I met, and I figured out which field interests me the most. Thank you.
Thank you very much for sharing these talks, actually these dialogues, I would say, because everything was thought to be a continuous, I would say, narration among what in the practice Stefan with the association are doing since several years, and what also this make to Lisa, that was students like many of you have been or are still also participant in the Talete programs, have the chance to also explore something, I would say, an experience some at the beginning quite blurred, but I still remembering her passion and her desire in well, addressing this topic beyond the fact that she was sure that she would have been experienced many and learned many things new, but because she truly believed in that. And so I think all this discourse from her and reconnected to Stefan really show the emotional and the feelings that she has in this topic, in the field, in this experience. So we still have some time. I think there are some questions also online or here inside. So please, for the people who are here, if you want to join here to ask if there are comments, question, curiosity, and online also. I think we have some questions, right? Do you have? Please, you want to come here?
I would thank you for the presentation, first of all, and I would like to ask mainly about the civil engineering side. What's the construction time compared like to the other traditional construction methods used in the region itself? And what's the performance regarding like the earthquake I mean, side the seismic evaluation of the constructions?
You can both reply as you prefer.
Okay. Yeah, as for the building times, it's absolutely comparable to the local manner to build. So it is absolutely usual to build a complete house or also small public buildings. Can you hear me? Okay. And okay. So it's completely normal to build complete buildings without mechanical tools in this region, and so it doesn't make a big difference if you use then concrete or bamboo. It doesn't. Bamboo can perhaps even accelerate a little bit because you have, of course, the training aspect that takes time, because you have to get familiar with all the connection details and all this stuff. But once you have it, you can replicate it quite quickly and build large volumes with very few material. This is one aspect. And then you were asking about earthquakes. Okay. As for the earthquakes, bamboo is quite resilient from this point of view because it's an elastic material. It's a natural fiber that can stand earthquakes if it's correctly connected structurally. This is not really a problem. As for the earth, I almost would say prejudice comes very often that Earth doesn't stand earthquakes. It's a pity that I don't have the slides. I have images on that where you can see if there are maps, global maps, where you can where the regions with a strong tradition in building with earth is mapped, and then you can have a similar map with all those regions that are affected by earthquakes regularly. Italy among them, and there are a lot of suppositions. So there are regions who traditionally built with earth in earthquake-affected regions. So there must be a solution, and there is. If you think about the rural building that I showed from Abruzzo, from central Italy, for example, just to mention, they have walls with a conical shape. So they're very large at the bottom and very slender on top. This is, for example, one measure taken through experience, through trial and failure probably. But then they got it that this can be a response to stand earthquakes. And we know we had an earthquake in Abruzzo not so many years ago. In 2009, they had a strong earthquake, and these buildings are still there, so it works.
Hi, hello everyone. Are you listening to me?
Yes.
Oh, congratulations, Polak, on your presentation. I'm Katia, professor in Brazil who work with sanitation infrastructure, especially water security, governance, and climate change, and that a topic that I will present some experience on Trento in May. Stefan, you addressed the relevant and contemporary theme that we need to pay close attention to going forward, revising our quality of life standards and the low impact technologies to prosper more independently of natural resources. And in this sense, I would like to know about the financial investments needed to implement such an experience and thus encourage the construction of projects of this nature on large scale. And is it possible to estimate the cost, for example, per square meter in euros or dollars for these constructions by type of material, and how long on average these projects might take? And the reason I'm asking you, because when I worked as an advisor in different municipalities in Brazil, in the state of São Paulo in the Amazon region. And the time and the cost of constructions are the first parameters that public managers consider important rather than longer-term benefits. And could you provide us an average value and a time estimate for these projects? Thank you.
Okay. Thank you, and thank you for the question, because it gives me the opportunity to say a few things that I forgot before, or that the time was not there. So first of all, referring to the project that we do in the Global South, in regions like the ones that Lisa also showed, the Central Ivory Coast, also, they're choosing materials like raw earth and bamboo that are locally available and that can be sourced with really simple tools by the people living there, is of course a matter of emancipation. It's a financial emancipation. I don't need to transport industrial objects that come from, at least from the port of Abidjan, or probably from Europe, or don't know where, and which have to be bought with financial solutions that we can't even imagine. So in this sense, for the local people, it's an interesting opportunity to say, okay, I learned to build with bamboo, and I can make roof structures with this, for example, and I can perhaps think of growing my own bamboo in a perspective, because for the moment they only take the spontaneously growing bamboo, but this can be a perspective. As for the other half of your question, so let's say that the relation to public buildings or larger buildings with strict estimates and all these issues, I can perhaps provide some figures from the experience I'm having in the last 2 years. I'm working for a municipality in Germany, and there this issue also comes around when we have a small design team in the municipality, which is very interested in promoting building with natural materials. But of course, then when we go to the city council or so, the first question is, what does it cost and how long does it take? And this is why I can answer this question a little bit, because we had the calculation, for example, on a building that we are planning to build with a timber frame filled with straw bales. So this is a specific technique that we didn't show tonight, but really locally sourced material. Straw bales are available there in the region, timber as well. And we found out that it has an extra cost, which is between 4 and 5%. So really not so much, and this and we managed to convince the city council to accept this, especially with the argument that at a certain point the building will close its life cycle, and this is a problem that we experience often now. When we dismiss buildings built in the 1960s and 1970s, we have so much trouble with building materials that are not natural, because we have asbestos, we have polystyrene of all kinds, and all these things that were used because it made sense at that time. I don't want to judge. Asbestos was a very performing material, and at that time when it was employed, it was not known that it can cause cancer, so it made sense to use it. But now we know it better, and we have to deal with it and to dismiss it. And we are convinced that if we invest today on completely natural materials, we can avoid this problem in 30, 50, 60 years for the dismission, because as I was telling, for the raw earth, for example, this is completely recyclable. It is a circular material. The vegetable rods, if they don't perform anymore, at least they can be composted and become fertilizer, and so on. I don't know if this answers your question.
Yeah, perfectly. Thank you, Stefan. And I would like another question to Lisa. Is it possible? Lisa, your presentation was inspired. It reminded me when I graduated and I went to live and work alone in Amazon region at age 26, visiting different places, locations with high environmental impact and human interference in 1998. And in that sense, I would like to know what it was like for you to have this experience. What is the aspects that reach your career and technical expertise by being close to the tools, developing projects, and literally building them in those different places. I imagine it was a unique and fantastic experience that you never made from your memory. And you talk a little bit when you were finishing your presentation, but I would like if you can share other aspects or feelings that you have, because it's very important for any career.
Thank you for the question. This experience for me it was really interesting, and I have many memories of these days. I learned a lot of things because I do many practical things, and I learn from that. And this is the best things I do there with Stefan, but also with the young builders that help me to do many prototypes with the bamboo, the earth, and they were really really kind with me, and so I met really many helpful people that helped me to learn by doing. So to learn by doing something concrete. So I hope to return with Stefan soon.
Perhaps I can add a little detail on that, because with this training program that we did, and where the collaboration with the Talete program was a part of, we had also the ambition to install a builders cooperative on site, and it almost looked like we succeed in that because we gathered 10 young people. They were bricklayers and carpenters mainly, and who started the process to build up a cooperative. At the end, they didn't really dare, so they were a bit scared. So this enterprise did never really start completely. But I think what I know for sure is that singular members of them are applying the techniques that they learned with us as private bricklayers and carpenters, and this makes me very happy, I must say.
Prova. Okay. Thank you so much for the very interesting presentations. I have two more technical questions, actually. I really trust to your building. In my opinion, I would really like to buy my own home by raw materials right now. But there is something that it's not completely clear, as starting from the small experiment that you made as trying right now. I'm not understanding how is it possible that the water among the different size of the particles, and especially in the clay. How is it not evaporating at a certain time, and so making the entire structure collapsing? Because I understood when you mentioned the importance of having good boots and good hat, but after you also mentioned that you are planning a basement in raw materials. So in that case, humidity, of course, comes up from the bottom. So if you can please clarify a bit more this aspect, because I really trust, but you know, we are engineers and we cannot just trust, we have to really understand. And secondly, which are maybe the tools or the parameters that you use more to understand where to start to escape, to take the good materials in order to avoid or to reduce in general the humus consumption that is, of course, an aspect to consider to avoid the soil consumption.
Okay, I would like to start from this last question. Normally, we say roughly that the humus layer is approximately 60 centimeters. This is, of course, an estimate that can't suit all sites. There can be differences. If you are along a slope, it might be less. If you are in a valley somewhere, it might be more. But this is something you can easily assess with an eye monitoring. You look at it, or what you also can do, you can smell the excavated earth. If it smells organically, you recognize it that it's not suitable, and then you can always already renounce to use this part of the soil and go deeper. This is something you can easily do. Then the assessment, Lisa showed a picture with different empirical methods. The thing that I always suggest by doing empirical testing methods, it's of course to choose the right number of samples. Because you can't take conclusions from one sample, of course, because it could be exactly the exception. So a row of 5 or 10 samples for each test, and then crossing the references that you get from the different tests is also so. Running more than one test is another good advice to understand how the earth behaves in that case. Then if the earth is not suitable, you can blend the earth, because probably from the test you will already get a hint to at least what is missing. If it's as we talk, for example, about blends that are too fat, if they contain too much clay. And the clay, as I tried to explain, is the glue in our aggregation, is in our blend. But we need aggregates, because actually the spherical aggregates are those who give the structure, those who can bear loads, but glued together by the platelets of clay. Okay, and so if the proportion is not right, this is something that beginners get easily wrong, because they think, oh, the more clay, the better. Because since this is but if you understood how the clay behaves underwater, then you know how risky this can be. We need the structure, and perhaps this answers also your question about how much water can clay construction absorb before collapsing. It is, I was talking about the right amount, and I put it in. So that I cannot say what is the right amount of water in percentage or in grams or so. I'm not able to say that. This depends. Every earth has to be assessed, and you have to get close to this result by practical experience. This is you can't avoid this passage, because an earth can have some properties. If I dig it there and 10 meters long, it can be completely different. So this needs to be done. But Earth has this possibility to absorb quite a good amount of water, and this is the aspect that allows Earth to be a good stabilizer for the inner climate. When it gets too dry, too wet,
it can collapse. This is something we need to know at a certain point, and this is something we have to avoid. This brings me to the basement issue. I think the head is clear. A large roof can protect the wall of getting wet, and so this protects. From underneath, it's mainly the effect of dropping water, because there we have a double effect. We have, when it rains, you can have diagonal rain if you have rain and wind together, and as long as it hits the earthen surface and then washes away, it can cause a little bit of erosion on the wall, that the wall gets thinner and thinner through the centuries, or through the decades, let me say. This can happen, but this is not really the problem. Problem would be if you have the double effect of diagonally arriving water, and then the water that falls on the floor and hits again on the wall, and this can erode the basement. This is a critical point, because there it's where the heaviest load is on this point. This is to avoid. That's why it's a good advice to build the boots of the building with a hard material that can stand this effect. Hope this answers the question.
The clay and the other rocks, so
yeah,
it doesn't evaporate on your home.
It cannot evaporate from the core of the building element. Let's say it can evaporate once it is on the surface. That is possible. Yeah. Yeah.
Without.
Qui. Sara.
Sì. Vabbè, bravo,
Prendi questo.
Ok. Poi, allora, no.
Dai, vieni qua.
Grazie, ok, prendo questo qua. Ok, adesso sì. Okay, no, I was saying that without giving an answer with numbers clear would have been disappointing an engineer, but at least we convince you, no? Even if we didn't say exact amount of proportion, no, by joking, yes. I think, I don't know if we still have time or we still have any other questions, no? Okay, perfect. So, yeah, we are ready. You always can.
Once again, thank you for your very interesting presentation. My question is concerning the scaling up these applications in specific contexts of international cooperation, for instance, in informal settlements to improve the household of poor people, considering the time and the costs of such constructions. What about it? And the second example I'm thinking of is the refugee camps. Did you consider the opportunity to scale up these techniques in order to facilitate the improvement of condition of life of refugees and displaced people? Thank you.
Okay. Honestly, we didn't deal so much with the emergency issues. We are more concentrated on the development aspects to make it longer lasting, and to invest in these contexts where there are stable residents that can deal with the techniques and with the socio-economic implications of it. This is a bit the issue we dealt with till now, but I can easily imagine that it can help for emergency situations as well, especially if we think about the replicability. So if we have this process of learning by building, plus a local availability, a sourceability of materials, then you have both things together. You have the material that you can source easily and at low cost from the surroundings, if this is given, because it's not It's not, we can't give it for granted. But if we have this aspect linked to transmission of know-how, then it can certainly be a solution also for what you're saying. The other aspect, as for the scaling up, if you need a quick upscaling, this is why I introduced the pictures with prefabrication aspects, because this can, of course, accelerate if you think. So the large buildings that I showed from Switzerland or Germany, they have a bit another approach. They have the preoccupation of the need of interrupting the building site activities during winter. And this is why they came up with this hangar solution. So they said we can prefabricate the facade in a protected hangar. We can work from October to February in this condition. And in March, we can start to bring the elements out. But why not thinking about a similar thing in other climatic conditions? We're talking about Thailand. Of course, this can be an issue that you say you spread the production of building elements very widely, and so you can accelerate it and scale it up. And then you transport these elements not on long transportation ways, because that would take the sense of building with local materials. But if we think about a radius of 10 kilometers, it may be okay, and perhaps possible.
Well, I really, really thank you a lot for this conversation, for these dialogues, and also for the conversation that came out after these two presentations. I think, well, beyond being a construction material, raw earth, it's really show us also the powerful meanings of an approach that drive design as a process. And I think it's to learn how to do it, to exchange. Elisa said the mutual learning that she experienced, but also this experience of building that your association are sharing. It's really in the essence of knowing the material in the site-specific place and understanding from the detail, from the smaller scale of the material up to the larger scale that this can be built. So it's a very powerful and inspiring talks that help us also to bring something more, learn from the specificity of the material, but also to empower other process, the general process of design, also in other contexts with other materials. So really, thank you again a lot, Stefan and Lisa, for being here with us to this evening, and also to all the participants for the active presence. And so thank you very much.
Thank you for the invitation.
Susanna, please wait. Susanna needs to say something.
Just
yes.
a quick information. Thank you. Just for the audience, next appointment will be next Thursday, the 26th. Yes, if I'm not wrong. And it will be on critical mapping with Federico Monica and Chiara Brauker. But great. You will be informed. And if you're a student and you're looking for a credit type F, please sign. Well, okay, no, probably nobody of you, but thank you again and see you next week.